18 billion kilometers from the Sun, two tiny probes drift in the dark, their golden records still whispering our message to the stars. Beyond the heliopause, the invisible wall where the Sun's light fades into cosmic night, Voyager 1 and 2 have crossed into true interstellar space. Out there, between frozen dust and the quiet breath of distant stars, they drift, the last echoes of our civilization still traveling outward. But tonight, something different is happening. For the first time in years, the signal isn't only leaving, something is coming back. We once sent our voice into the dark, hoping someone might hear. Now, it seems the universe is answering. Alpha Impulse, hidden in the static, the first whisper of a new visitor. This is the story of that traveler, the third to ever cross the cosmic boundary 3, I Atlas, on the night of July 1st, 2025. The Atlas telescope in Rio Hurtado, Chile, recorded a faint moving point of light. At first, it looked ordinary, one more dot in the sea of stars. But unlike other surveys such as Pan-STARRS or the Catalina Sky Survey, Atlas was scanning a place few telescopes dare to look: the bright, crowded galactic plane. Most instruments avoid it. The light is too intense. The sensors risk overexposure. But Atlas had something different, a system built to tame that brightness, to look where others could not. And that night, in that forbidden glare, it caught a visitor racing toward our solar system. At first, it was just a faint dot. But within days, the data whispered something impossible. When astronomers traced older images, they realized the Zwicky Transient Facility and 3 other Atlas telescopes had already captured it back in mid-June. A pre-discovery, hidden in plain sight. It had been hiding in our data all along, waiting to be found. At first, the strange object was labeled A11PL3Z, just another coded entry in a database full of sky wanderers. But as more data poured in, it became clear this was no ordinary traveler. Soon, it earned a new name: 3 I Atlas, the third interstellar object ever detected passing through our solar system. Later, when its faint coma was confirmed, it gained yet another identity: C2025. None. The letters tell its story: C for comet, 2025 for the year of discovery. None marking the first found in July. Its official name came from the Minor Planets Center in Cambridge, Massachusetts, the gatekeeper of every visitor entering our solar system. From there, a single alert spread across observatories worldwide, accompanied by a chart showing its hyperbolic orbit, an unmistakable sign of something born beyond the Sun. But what froze astronomers wasn't its name, it was its speed. When scientists measured its motion, the numbers made them pause. 58 kilometers per second. That's the length of nearly 580 football fields every single second. By comparison, Oumuamua, our first interstellar visitor, entered at just 26 kilometers per second, and Borisov at 32. 3I. Atlas is moving almost twice as fast, faster than any comet we've ever recorded. Its orbit is extreme, a hyperbolic path with an eccentricity of about 6, meaning it's not bound by the Sun's gravity at all. It will enter, curve once, and then vanish forever into the deep. And there's more in the vast dance of the galaxy. Speed often tells age. The older a star, or a fragment born beside it, the faster it tends to move through the galactic sea. So perhaps this comet has been wandering for billions of years. a relic from the dawn of galaxies themselves. It's not just speed, it's memory. The faster it moves, the older it may be. A traveler unbound by any star. In late October. 3. I Atlas will reach its perihelion, the closest point to the Sun, on October 30th. At that moment, it will pass just inside the orbit of Mars, at a distance of about 1.4 astronomical units, roughly 210 million kilometers. Astronomers are calling this window the watch zone, stretching from early October to mid-December, the best months to follow the comet's passage. During this window, the comet will appear brightest in the morning sky before dawn, when the air is still and the sun just below the horizon. For northern observers, it will rise low in the east, along the equator. It cuts across the faint glow of the Milky Way, and in the southern hemisphere, it sweeps higher and faster before fading behind the sun. A watch window calendar now marks the key stages: October approach, November Schubler crossing, December re-emergence. Compared side by side, its orbit sits between Borisov and Oumuamua, not as shallow as Borisov's, but less steep than Oumuamua's daring plunge. As it glides past Mars, we may witness something no telescope has ever recorded since Borisov, a glimpse of an interstellar traveler bathed in the light of two suns. When astronomers from the Las Cumbres Observatory in Hawaii pointed their telescopes at 3I Atlas, they were looking for one thing: a rhythm. Over a full night of tracking, they recorded subtle variations in brightness, a slow, steady pulse every 29 hours. The change was only 0.2 in magnitude, almost flat. For comparison, Oumuamua's light curve swung widely, flashing and fading as it tumbled through space like a shard of rock. But 3I Atlas was different. Its calm light curve may hint at a sphere, not a shard, not a pancake, but a perfect traveler if its surface is evenly coated in dust. It would reflect sunlight almost uniformly, explaining why its glow barely changes as it spins. Imagine its light curve, like a living heartbeat, light pulsing softly, like the heartbeat of an ancient wanderer drifting between stars. From the gathered data, astronomers estimate that 3I Atlas spans nearly 10 kilometers across 10 times larger than Oumuamua and several times bigger than Borisov, whose core measured only 1 to 2 kilometers. In just a few months, its brightness has increased from magnitude 20 to 17.8 as it moves closer to the Sun. That change might sound small, but in astronomical terms, it means the comet is reflecting almost 6 times more sunlight than before. The brightness we see depends not only on its size, but also on its albedo, the fraction of sunlight it reflects. A high albedo surface, like ice, shines vividly. A dark one, covered in dust, barely glows. 3I Atlas seems to belong to the latter, massive, silent, and wrapped in a thick, insulating layer of dust that keeps its interior cold and calm. This could explain why, despite its size, it shows so little visible activity. No violent jets, no bright outbursts. Only a steady glow, massive, silent, and self-contained, as if protecting secrets beneath its crust. Images taken in early observations revealed a faint coma, a soft, glowing halo surrounding the comet's nucleus. Its tail measured barely 3 arcseconds across the sky, translating to roughly 25,000 kilometers in actual length. In those tracked images, the background stars appeared, smeared and blurred, proof that the telescope was following the comet's motion, not the heavens behind it. compared to Borisov, whose tail stretched 140,000 kilometers and vented 50 kilograms of dust every second. 3. Atlas seems almost restrained calm. Deliberate. Composed. Yet the story of this comet isn't told by professionals alone. From Chile to Japan, amateur astronomers join the chase, uploading their own images, refining measurements, and sharing updates through the astronomer's telegram each night. What began as a distant data point has become a shared human discovery, a reminder that wonder still unites us beneath the same sky. Perhaps it sleeps now, dreaming of the star it once called home. When astronomers analyzed the reflected light from 3I Atlas, they found a clear signature. It was redder than the Sun, and even redder than D-type asteroids from the outer belt. That deep, rusty hue often means one thing: carbon. Over billions of years, radiation from cosmic rays can bake and oxidize the surface of such objects, leaving behind a film of reddish organic dust. It's the same process that turned many of the ancient asteroids in our solar system dark and dull, compared to Borisov, which carried an unusually high amount of carbon monoxide, a clue that it formed around a cold, carbon-rich red dwarf star. 3I Atlas appears to share a similar heritage. This suggests it came from an older region of the galaxy, where the first generations of stars had already lived and died, enriching the space around them with heavy elements and frozen gas. If its true age is 11 billion years, it has seen the universe before Earth even existed. In the grand archive of interstellar visitors, there are only 3 names that matter so far. First came Oumuamua solid, mysterious and tailless, a fragment of rock that spun like a knife and vanished without a trace. Then came Borisov volatile, brilliant, chaotic, shedding 50 kilograms of dust every second as it tore through the inner solar system. And now, 3I Atlas, massive, calm, enduring a visitor of silence rather than spectacle. If you map their paths together, the picture tells a story. 2017. 2019. 2025 3 curves crossing the Sun's domain, each from a different direction, each with a different soul. Oumuamua was a question, Borisov a revelation. 3I Atlas, a mirror reflecting how little we still understand the world beyond our own. And then comes the quiet moment, the oldest traveler at 58 kilometres per second. It may have wandered for 3, perhaps 11 billion years. Its speed is its story, a lifetime stretched across galaxies. 3 travelers, 3 messages, and none alike. Why are the 3 interstellar visitors so different from one another? Some scientists suggest they are fragments of ancient planets, worlds torn apart by tidal forces near their dying stars. Others believe they were born even earlier in the chaotic dawn, before our Milky Way was fully formed. And some imagine them as drifters, loose clusters of dust and ice, slowly merging inside the cold, vast interstellar medium. In a 3D reconstruction, 3I Atlas appears to have once escaped an ancient red star cluster, breaking free into the dark sea beyond. Statistically, astronomers estimate there may be only 0.001 interstellar objects in every cubic astronomical unit of space. That's like one wanderer drifting alone in an ocean of billions of miles. Maybe it's just ice and dust. Or maybe it's a mirror showing us how little we understand. The watch window calendar returns October, November, December, illuminated by the soft glow of the sun. 3 triggers to watch in the months ahead. Solar when the BZ component drops below -10 nanotesla for more than 2 hours. Comet when R2 Swan reaches naked eye visibility. Seismic when a new magnitude 6 plus aftershock appears within current clusters. You can track it yourself. Live. Just type its name on NASA's JPL Horizons tool. Perhaps it's just a frozen speck adrift in the void, or a reminder that the universe still watches us back. Subscribe and stay on watch when it re-emerges. We'll be here. The faint hum of the wow signal fades out, and the screen falls to black